We discovered a new pathway by which a class of drugs called PARP inhibitors are able to control the growth of breast cancer cells. PARP inhibitors are currently used in a subpopulation of breast cancer patients who have a particular genetic marker called BRCA, and that's typically around 10% of the populations. By understanding this additional pathway through which the PARP inhibitors work, we could potentially expand the population of patients who would benefit from the PARP inhibitor drugs by 2, 3, 4-fold. Perhaps 70% of patients instead of 10% of patients might receive some benefit from the use of the PARP inhibitors. PARP1, which is the main target of the PARP inhibitor drugs, interacts with a protein called DDX21. And this is a protein that is essential for a process called ribosomal RNA transcription. The ribosomes make proteins that are essentially the structural and functional elements of this house that is the cancer cell. So if you take away these proteins, the house will crumble, and essentially that's what the cell death is for the cancer cell. One of the things that we'd like to do now is develop some prospective clinical trials where we can look at some of the biomarkers that came out of our work, biomarkers that might indicate whether the PARP inhibitors would kill the cancer cells in those patients. My hope would be that one of these biomarkers that we've developed could be used in everyday clinical practice as something that is, a useful test and can help save the lives of patients. This could include patients with additional cancers such as ovarian cancer, where PARP inhibitors were first tested and developed, as well as prostate cancers and beyond.